Alright, welcome back. So in this particular video, we're going to actually see how we're going to build the various models, right? We're going to build different models, and then we see the performance of these models. We're also going to do some hyperparameter tuning to get the best performance of these models, and then we're going to use that best model, and then we're going to deploy that best model into production, right? We're going to deploy that best model via the Heroku platform. All right, so let's get started with it. Now, what we're going to do first is to actually split our data into training and testing data, right? So we're going to use our train test split function, which we've been using in our previous videos, right? So I'm quite sure you're familiar with this train test split, right? So in sklearn.model selection, we're going to actually use train test split to split our data into training and then testing, right? Remember that earlier on we divided our data into dependent and independent, right? That is X and then Y over here. Okay, so that's the the data set that we're going to use over here. So you can see that we're passing in our X and then we pass in our Y. All right, so in this case we're going to use 80% for training, and then we're going to use 20% for testing. So you can see our test size over here is 0.2, which is saying that we're using 20% for testing. All right, so the part of the X that will actually be used for training is going to be stored in strain, and the part of the X that is going to be used for testing is going to be stored in a variable called test. Okay, the same thing, the part of the Y that is going to be used for training is going to be stored in Y train, and the part of the Y that is going to be used for testing is going to be stored in a variable called Y test. Okay, so that is done. I mean, this is going to be done randomly, so we use random state equals 50. You can just choose any variable name. I mean, any value here, right? So what we actually want to do is that we don't want different random variables to be, or different random values to be generated over and over again as we run our code again. Okay, we want the same random variables to be generated, so we random values to be generated, so we use this random state equals any number that we want, so that we take care of that. Okay, so we split our data. Now we have our training and then testing data over here, right? So that's what we're going to use moving on further. All right, so the first thing that we're going to actually do is to actually just try with this extra trees regressor. I remember that when we're dealing with the Zomato app, when we're building the Zomato app, when we're deploying that, we found out that extra trees regressor was giving us a good accuracy, right? So we're going to try that over here and see if it's going to work, right? We're going to also use different other algorithms to build this model to see which one is actually going to do well for us. So from sklearn.ensemble, we import our extra trees regressor, and then we initialize it over here, right, with an n estimated to be 120, right, and then we fit our model on our S train, and then the Y train, that is our training data, right? So we fit it on the training data, and then after it has learned from the training data, right? So fit means learn, so it's just going to learn from the S train and then the Y train, right? So after it has learned from that, what we're going to do is to make some predictions, right? So we're going to use, remember that our model is called AT model, right? So we're going to use this AT model to make some predictions, right, on our test data, right? So we're going to make some predictions on our test data over here. Okay, so that's basically what we're doing, and then we use this R2 score, right, to actually check, which is a metric. So we're going to use that to actually check the performance of it on the testing data, right? That is the Y test and the predictions that we did, right? So we're going to actually see it, how close our prediction is with the data set that we have, right? So with the actual data set, right? So when we check the score of that, we can see that we have around 76% or 77% over here, right? So not that bad. It's just, the accuracy is not that bad, but we can actually do better than that, right? We can do better than that. So the next one that we're going to actually check is random forest. Okay, so we're going to use random forest regressor. Now, since we are predicting the price, right, it's actually a regression program. That's why we're using regression algorithms, right? So we started with extra trees regressor, right? So we are predicting the price, which could be in let's say 12,052 rupees, right, or maybe $15.5, right? So something like that is actually in the form of a decimals. It's actually going to be in a decimal form, so it's actually a regression problem. We're going to predict something which the outcome is going to be in a decimal form. It's going to be a regression problem. Okay, so just take it in a low man's understanding. If you're going to predict something which is going to be in the form of a decimal, say the price of a household, or maybe the stock price of say Apple, right? It's going to be in the form of a decimal form, so it's going to be a regression problem, right? Something that is continuous. Okay, so that's basically what is going to happen over here. All right, so we actually import this random forest from sklearn.ensemble, right? So we import random forest regressor, and then we initialize it, right? We initialize it, and then we fit it on the training and the test. The training data, right? So this is where the 80% of the data is being used, right? That is the X train and then the Y train, right? We make our model, our RF model, which is nothing but random forest model, to learn from, right? To learn from the X train and the Y train over here. And then we make some predictions. We do this because we're going to need our predictions. We need to compare our predictions with the actual Y variables and values that we have in there, right? So we're going to compare these two and see how close they are using the R2 score, right? So when we do that, we can see that this one is doing 79% as against extra tree regressor, which was doing 76%, right? This one is doing 79%. So this is quite better than the one that we used earlier on, right? We can still do some hyperparameter tuning to actually get better accuracy, right? So over here, what we're going to do is to use this randomized search CV, right, which is actually going to help us to do this hyperparameter tuning, right? So we're going to actually use some hyperparameters in here. You can actually change each of these, right? You can change each of these that I'm using over here, right? If you don't know, what to change or what to use, right? I'm going to use this. If you can actually just search this randomized search CV, and then you can see the hyperparameters that you have over here, which you can actually tune. So if you just go to say if you just search this on Google, right? So if you just search this on Google over here, right? So you can actually see the various hyperparameters, right? The parameters that you have inside here, right? So these are the parameters that you have. You have explanation of all these parameters over here, right? You have explanation of all these with even examples in the here, right? So if you don't understand any of them, any of them that you need to tune, right? You can just search like that and you can actually get to them. So we have n estimators in there, right? So for n estimators, if you remember earlier on, I just, for instance, extra trees, I just choose n estimators to be 120, right? But how do I know maybe 150 is better, or 10 is better, or 20 is better, right? So for that, what I'm going to do is to actually do this. I'm going to actually do it for several of them. So I'm going to start from say 80 to say 1,500, right? I'm going to just do it several times over there, right? So that's basically what I'm going to do. And then I have max features. For that, I'm going to use auto and then square root, and then the maximum depth over here I'm going to use from 6 to say 45, right? So that's what I'm going to do. And then the minimum splits, I'm going to use a list of them, and then the minimum sample leaves, I'm going to use a list of them over here, right? So over here I will just create a dictionary of my random grid, right? Because I need this random grid over here, right? As a param distributions, I need that over here. So I'm going to create it over here, but it's nothing but those n estimators that I've already created, right? So you can see that I have n estimators over here, right? So that's just the same thing. I have max features over here, then max features, I map it to max features. So it's just the same thing that I have over here, that I've created a dictionary for it. Okay, then I have my random forest regressor over here. I just initialize it, right? Because that's what I'm going to actually use over here, right? That's what I'm going to use over here. So I use the random search CV, right? So I store everything in a variable called R CV, right? So I put in all those hyperparameters that I've chosen over here, and here my scoring is negative mean square error, right? So that's what I'm going to use, and the number of iterations that I'm choosing is going going to be 10, right? I'm going to do this around 3 times, and then since it's going to be random, I'm going to set this to 42 and the end jobs to be 1. All right, so as I said, you can just get all these hyperparameters over here, right? You can just get each of them over here. All the explanations are here that you can actually get to know, and some examples for you over here too. Okay, so now that is done. If you don't know which one to tune, you can just do it that way, and then you can just change it. For instance, I started from 80, right? You can just start from say 20, right? You can just start from 20, and then maybe I ended at 1,200. You can start from say 150, or maybe you can end at say 2,000, right? So you can just tune it the way that you want, right? You can just do it the way that you want. All right, and then see how it is doing well for you. If it's not doing well, you go back and tune it again, okay? And you go back and tune it until it gives you a better accuracy. All right, so after that is done, after I have this done, what I'm going to use is to, after I've created this model, what I'm going to use is to actually we use it to fit, right, this S train and then the Y train, which is my training data, right? So I use rcv.fit to make my model learn from the training data. Okay, so when that is done, what I'm going to do is to make some predictions, right? So as I said, I need this prediction variable so that I can be able to compare it with the original variables and see how it is doing. Okay, so I use that rcv.predict on the S test, right? That's test data. And then after that is done, what I'm going to check is the mean absolute error, right? I'm going to check the mean absolute error and then the mean squared error, right? I'm going to check that on the Y test and then also the prediction one that I did, right? I'm going to do it for both of them, right? So that's some of the metrics that you can actually check. So you can see that I have this match mean square error as against this match mean absolute error, right? So in order for this to be a bit clear for you to see what is going on here, I'm going to use this R2 score, right, on the same thing, which is the Y test and then the RF print that we did earlier on, right? So you can see that this is also making giving us 80% as against what we did earlier on. We're having 79% and then 76%. So you can see that this hyperparameter tuning is actually working for us. It's actually doing well for us, right? Making 80%, right? Now we're also going to check. We're also going to use other algorithms that we think might also give us a good accuracy over here. So the first one that we're going to use is cat boost, right? So if you don't have cat boost, it's just simple. Yes, use pip install cat boost to actually do that. So I did the same thing. Then since I have it, it's going to be requirement already satisfied for me, right? So if you don't have it, you just install it. You just use pip install cat boost and you can easily get it. Okay, so after that is done, what you're going to do is to do from cat boost import cat boost regressor. Okay, since it's a regression problem, we're going to use cat boost regressor to do that. Okay, all right, and then we initialize it, right? We initialize our cat boost over here and then we fit it, right? So we initialize it to a variable called cat. We use cat to fit on the training and then our training data. It's just the process is always the same. You first import your algorithm, you initialize your algorithm, then you fit it, right? You make some predictions and then you check the score. It's just always the same thing. All right, so this cat boost is actually going to do a lot of training over here, which is going to be quite long, right? It's going to do a lot of training over here, right? It's going to be do a lot of training over here. This is going to take a little bit of time, right? So you just wait for 2 or 3 minutes for this to get done. All right, so it's going to do quite a lot of training over here, and let's see let's make some predictions over here and then check the score of that and see how well it's doing. All right, so we use cat, we just make some predictions, cat.print predict and the test the data, and then we store it in a variable called cat predict. All right, so we're going to actually compare this cat predict with the original Y test data that we have over there. Okay, so we check the R2 score of that, and then you can see that we have 83%, right? So you can see that Card Boost is actually doing well, right? So I mean, once you're doing this, you don't need to end at one algorithm. I mean, you can check several of them, even though we did some hyperparameter tuning, which was, I mean, doing well for us, which was giving us 80%, but still you can see that Card Boost is actually doing better than that. You can actually see that Card Boost is actually doing better than that. All right, so we're going to also check for light GBM, right? You're going to check for light GBM. So let's do that. If you don't have it, it's just to pip install light GBM, right? And then you can get it. Okay, now for this actually require us to actually change some types over here, right? So if you get any error, just use this, change the type of say duration hour, and then duration minutes, right? And then also duration hour and duration minutes in either of them, in either string and then I mean in both of them, string and then test, right? You just change it, change the type to say int, right? And that will work for you. If you encounter any error, just use that. All right, now after that is done, after you change the type to say int, right? Now what you're going to do is to do the same process, right? You just from light GBM. Now if you installed light GBM, so you can just import light GBM and then you use that. So we're going to use light GBM regressor to actually do that. Okay, so you can see that over here we have LGB model, so we're going to create that. So as I said, you just import it, you just import your algorithm, you initialize it, and you fit it. So we just the same process, right? You fit it on your training data. Now after that is done, what we're going to do is to actually make some predictions and then check the score, right? To make some predictions and check the score, just like the normal process that we do. And then over here you can see that we have 80%, right? I think Card Boost was doing better than that, right? 83%, that's against light GBM, right? So let's check for SG Boost too, right? Let's check for SG Boost. So if you don't have it, you just do pip install SG Boost, right? Just the same process, and you're gonna get that. All right, so it's just the same thing. You import your SG Boost, you initialize your SG Boost regressor, and then you fit it on the training data. You make some predictions and you check the score. Just the same process for all of them. The same process for all of them. All right, and you can see this is doing 82%. So I think so far what we have is I think so far Card Boost is doing better, right? So far Card Boost. I mean the second one is the second one which is doing quite well is SG Boost, right? But I think Card Boost is so far the best right now, and SG Boost is followed by that, right? Okay, so I think we can now make a conclusion over here which algorithm that we're going to use. So I think now we can go ahead with Card Boost, right? We can now deploy Card Boost on production, right? We can now, since that one is the one doing well for us, we can actually use that, right? We can actually use that instead of maybe the next one that we can think of is SG Boost, but since this Card Boost is giving us 83%, we're actually going to go with that. Okay, now if we see, say, the head of our data set, this is what we have. I'm going to save some part of this data set so that later on I will use it, right? It's not quite necessary, but I mean I'm going to use that so that, I mean, you will not forget. When I'm going to deploy this, I'm going to use that so that you not forget. I mean, you can just use this part, right? You can just let me uncomment this. Okay, what you can do is to just import pickle, right? If you don't have pickle, you can just install it. You can just import pickle and then you dump your data, right? You just dump your data. I mean, in this case we are using ET model, right, which is a structure regressor, but I think Card Boost was doing better, so we're going to go with Card Boost, right? So we're going to do that, and then I mean the only thing that we need is this model.pickle, right? That's the only thing that we need. So we can just use this part without doing the extra things that I'm going to do, right? Without doing the extra things that I'm going to do, right? So what I'm going to do is to just select some of the columns that I'm interested in, right? Over here, I don't need the root, I don't need the additional information. I'll drop that, then I'll save my data in another variable called deploy df, because I'm going to use it for deployment, right? So I'm going to save it to my local system, right? I'm going to save this deploy df to my local system using 2_csv, right? I'm going to use it later on, right? I mean, as I said, if you run this code, you're going to have this model.pickle, right? You're going to have this model.pickle on your system, and you will not need this part. You will not need this part. But if you don't run this, then you can save this so that you work along with me as I move on later on, right? So I think over here we're good to go with the cat boost. I think cat boost was the one doing well for us, right? Cat boost was the one doing well for us, so we're good to go with the cat boost regressor. And in the next video, we're going to start with the deployment part, right? We're going to start with the deployment part. So if you see the steps, this is the one that we did. We did the third part, right? We did the third part, which is get our data, prepare it, and then build a machine learning algorithm on it, and choose the best model. That's what we actually do. We actually just did, right? Build the algorithm, and let me actually add that, and choose the best model, right? So that's basically what we've done, and in this case our best model was cat boost, right? So that's what we're going to use later on. And over here you can see that we have create a web app using Flask. So that's our next step. In the next video, that's what you're going to do. So see you in the next video.